Yes.
If you remind me, I will get you a decimal, whatever chart there. What did I do? What did I do, say? Oh, the big machine thing. You can't really describe functions without describing relations first. Okay, a relation, as the book puts it, the technical definition of a relation is the pairing of two sets of information. Okay, for example, if I paired you all, here are you guys. Wait, let me do a bigger one. Here is the 8th grade class. And here is your shoe size. And I said, okay, number 1 in class. Who's number 1? Who? Jack, what's your shoe size? Let's stay away from the halves. Just give me the whatever number it is.
8.5.
Thank you for accommodating. 2, who's number 2?
1.
Okay. Number 2 is a 10, and I don't care if it's boys' side or girls' side. Number 3. 3. 9. Love it. 4.
7.
Does anybody have the same pair of shoes? 5. 7.
Yeah.
6.
9.
7.
6.
8.
9.
Alright, I'm stopping. I know you really wanted to give me a shoe size there. Okay. That is a relation just because I am pairing, I am grouping one set of numbers, your class number, to your shoe size. Okay? Now, the difference between that and a function, okay, is that a function, in a function, this thing is just driving me crazy. I push the thing down here, right up there. Yeah. Okay, a function says that every x value has only one y value. Okay. What that simply means here, which, by the way, this thing would be a function. It's a little tough to think about here. Get rid of this. What a function says is that, okay, every member of this first set, our first group is always our x numbers, and these are always our y numbers. What a function says is that, okay, this can only have one answer over here. Okay? And even though it could be the same answer as somebody else, okay, person number 8, whoever that was, had 9 for their shoe size, that is perfectly okay because the rule says, okay, for each one of these it can only have one thing over here. Now what would make it not a function is if, who's number 8? Is if Nathaniel not only wore a shoe size 9, but also wore a shoe size 6. Okay? Well, it depends on what you're talking about. Okay? Okay? So what you are not allowed to have, it is not a function if, okay, a single x value goes to 2 y values or more. Okay, it's still a relation, but it wouldn't be a function. Okay, because a function says that you can only have one x value or just to one single y value. Now, with that being said, we have, when we graph things, okay, in order to tell if they're a function, it is something called the vertical line test. Okay, and that means this. If you have a line, if you have a graph, okay, if you have a graph, well, let's just do a straight line. Okay, every straight line is going to be a function. Okay, because if you look at, here are all my x values, and here are all my y values. The vertical line test says this. First of all, you have to know what a vertical line is. Jeremy Schwartz, a vertical line is up and down or sideways? Up and down. Okay, you draw as many vertical lines as you want, wherever you want, however you want, whenever you want, however you feel like. The vertical line test says this, that if you draw as many vertical lines as you want, okay, each vertical line, okay, you can, it is a function if, is a function, I should probably say if it's not a function, is a function if all vertical lines cross the graph in only one place, or one time. In other words, my big black line here, when I draw all these vertical lines, it only crosses one time, each vertical line. Unlike this, I'll give you an example of what wouldn't be a function. Here is a not function. You've got your graph, and you've got the graph of something that looks like this. And there are graphs of those sort of things. See, if I draw vertical lines, all the vertical lines I want, okay, see how that graph of that line crosses more than once? This is not a function because of that. If at any place you can draw a vertical line and it crosses that graph more than once, it is not a function. Why would that be? Because at this point on the x-axis, you have two different y values. Now it can go the other way, mind you. I'll give you another example. You could have this be your graph. That is perfectly okay. Why? Because if you do your vertical line test, and you keep drawing vertical lines, is there any point where a vertical line is going to cross twice? No. So this is a function. Okay. How about this? What if I had this graph and this line? Function or not?
Function.
Yes, it would be. John, why? Where could I put a vertical line where it would cross it twice? Okay. Lauren?
What if, like, the graph or whatever and the line is like a straight looking down?
That would not be a function.
It wouldn't be-
Right. Because it would just simply be an x. Okay. Yeah. No. You cannot have a vertical line that would be a function at all. Now, with that being said, you also would have to recognize that if you're given a table of x and y values and coordinates and points, 1, 2, 3, 4, 5, 7, 8, 8, 8, 8. If I asked you if that would be a function, yes or no? Function, yes or no? Raise your hand if you think that's a function. Raise your hand if you don't think it's a function. Raise your hand if you got some input as to why you decided what way or another. Lauren Daffenberg.
Well, you said that, like, well, in like 8th grade shoe size one, some people have the same shoe size, but you said that one just can't have like 2 shoe sizes. And that one's okay because they're the same, they just don't have 2.
Going back to the, Lauren's relating it back to our shoe size thing. Okay, does every one of these have just one single y value? Yes. The only way something, this by the way is yes, this is a function. The only way you'd have something that wouldn't be a function is if it ended up looking like this. You would have to have 2 same x values have 2 different y values. You'd have to have duplicates here to give you 2 different y values. And if you want to see a case in point here, if I were graphing these points, Nick Shanks, because I could tell you they're kind of funny. If I graph these points, 1, 7 would be here. 1, 2, 3, 4, 5, 6, 7. 3, 8, or 2, 8 is right about here. 3, 8 is right about here. 4, 8 is right about here. 5, 8 is right about here. If you graph that, what would it look like? Using the vertical line test, would the vertical line cross more than one place? No, never. Now if I graph this, and I said 5, 2, 1, 2, 3, 4, 5, 1, 2, I put a dot there. 5, 1, I'd also put a dot there. 6, 0, or whatever 0. Then the graph of that line would look like something like that. And if you did the vertical line test there, it would cross that vertical line. So in order for something not to be a function, it'd have to be the same x value with different y values. You can have different x values with the same y's, but you can't have the same x's with different y's. It gets a little confusing, and that's why it's good to have a little bit of note and refresher thing there. Yeah, maybe we should take a look at something. I'm going to stop this and give you a little